Hi everyone. Today we are going to talk about 12.6 normal distribution. So we are going to find the number or percentage of data within one or two standard deviation of the mean when the data set is normally distributed. So we will talk about what it means, normal distribution, and learn how to find number or percentage of data within one or two standard deviations of the mean, right? So normal distribution is a probability function that describes how the values of the variable are distributed. So if any data set is normally distributed, it means this will be symmetric distribution like this. It's a bell-shaped curve, right? So it's a symmetric distribution where most of the observations cluster around the central peak. So most of the data are gathered around the mean, which is in the center, and the probabilities for values further away from the mean taper off equally in both directions. In both directions is exactly symmetrical, and extreme values in both tails of the distribution are similarly unlikely. So let's talk about the shape of this normal distribution, which is sometimes we call bell shape, right? So this exactly in the center, this is the mean, all right? Mean. So around the mean, exactly same amount, same data will go further. This way, the bigger, this way it becomes smaller, right? And we learned standard deviation, how far the data, right? All the data are how far away from their mean. One standard deviation distance, two standard from here to here, one standard deviation distance, two standard deviation distance, three standard deviation distance like this, right? But now, how many data are around here? But mostly the nearer the mean, the more data gathered in the normal distribution, all right? So this we call empirical rule. If any data set is normally distributed, the shape is like this. And how many data set is in this one standard deviation range? 34%, 34%, always exactly 34, almost 34% is in this section, and 34% is in this section here. So together, 68% of the data are located in the one standard deviation range from the mean. From here to here, how many percent of data is there? 68%. Then, if we use two standard deviation distance, if we go farther to standard deviation, how many percent of data will be there? 95% of all the data, all the scores, whatever, 95% of data are within two standard deviation. So 60%, if you subtract from 95, then it will be 27%, right? And the half of it, 27% is 13.5% is here and 13.5% here. And if we extend to the 3 standard deviation from here to here, then it'll be 99.7% of data will be ranged in this 3 standard deviation range. 99.7%, almost everything is there, right? So if you see it, this is about 2.35%, about 2.4%, all right? So how do you use this? Normally has one mode, median, and mean at the center of the curve. So here in center is the mean, right? And in the normal distribution, mean and median is the exact same value. Because mean is exactly in the middle. In other distribution, mean and median can be different, right? But in the normal distribution, mean is exactly in the middle, so it is median. And if you know that this mean has the most value than any other points, so that is also called mode, right? So mean has the most biggest data compared to any other points. So mean has the mode, right? So mean, median, and mean, and mode, median, and mean are all the same value in the normal distribution. And we know that this curve is symmetrical. So I just explained within one standard deviation, 68% of the values are existing. And then in 2 standard deviation, 95%, and 3 standard deviation, 99.7%. All right. So if you want to calculate each section, I divide into 6 sections: S1, S2, S3, S4, S5, S6. So if you want to calculate each percentage, then you should know that it's symmetrical. So this section is exactly the same probability, right? Same number of data will be there. So this is 34%, and this is 34%, together 68%, right? Because within one standard deviation range, we know that it's 68%. That's what we learned. Just remember it. So empirical rule, you should remember one standard deviation, 68%, 2 standard deviation, 95%, 3 standard deviation, 99.7%. That we call empirical rule. You should remember it. Then we can calculate each section how many percent like this. So S1, how many percent? You divide by 68% divided by 2 is 34%, 34% S2, right? S3, S4, I already told you, but how do we get that? We get this way. 90, so S2 standard deviation range is 95%, right? If you divide by 2, you can get only this section, half of it. So divide by 2, right? Half of it. 95% of half is 47.5%. And then what do you do? Subtract the 34 from S1, right? 34. Then you will get 13.5% for S3. And you know that S4 is the same. This way, if you calculate for S5, S6, so S3 standard deviation is 99.7%, right? And if you divide by 2, it's a half of here, half of this section. And then you subtract the S1 and S3, which is 47.5%. Then you get the 32.35% for the S5. And then S6 is also the same. Just practice with this, how to calculate each part, percentage for each part, each section. 1 standard deviation, 68%, 2 standard deviation, 90% of data is there, right? And the 3 standard deviation, 99.7%. This is we learned in the normal distribution. This is empirical rule. Always you can use that. Then let's use one example. So 4,000 students took the SAT and their grade is normally distributed with a mean is 1,100 and the standard deviation is 100. Then how many students are in the interval of 900 and 1,300? Now let's see, mean is 1,100, right? It is confusing. You better draw the number line and put the mean here in the middle, all right? That way you can do it. So how visually, right? Okay, you draw it like this. In the mean, in the middle, you have what? You don't need to draw everything like this. You can draw just a number line, just one line here, and put the mean 1,100. And then 900 is here, and then 900 is here, and then 1,300 is here, this side. But 1,100 to 900 is how many difference? 200, right? 1,300 is 200 more, 200 less, 200 more. How many standard deviation is 200? We should calculate. So we use how far from the mean, we use a standard deviation, right? How far, so we use a standard deviation. So 900 is how many standard deviation less from the mean? Because standard deviation is 100, so 200 is 2 standard deviation. So 900 will be here. Do you get it? Right, 2 standard deviation away from the mean, which is 1,100, right? So 1,300 also here, 2 standard deviation away. Then between 900 and 1,300 is how many standard deviation? 2 standard deviation, right? So we know that by the empirical rule, how many percent for 2 standard deviation range? 95%. 95% of the students are in the range of 2 standard deviation. So how many? 95% of entire students is 95% of entire students, 4,000 is 3,800 students are ranged between 900 and 1,300. Do you get it? Good. What if we change it to the 1 standard deviation range? Then how many students are there? 1 standard deviation. So 1 standard deviation is 100 less from the 1,100, which is 1,000, and the more is 1,100 plus 100 would be 1,200, right? So if you do it, 1,000 between 1,000 and 1,200, how many percent? 1 standard deviation is 68% by the empirical rule. So how many students are there? So you multiply 68% of 4,000 is 68% of 4,000 is 2,720 students will be in the interval of 1,000 and 1,200. Do you understand? Very good. We'll stop here.